Hey you guys, so many kids were out this morning for the governor's school meeting, so I wanted to talk to you about formal charge and how to do it. On Classroom you'll see this worksheet, and it includes the steps to calculating formal charge from all the way from how to draw a resonance structure in order to find formal charge, all the way through actually calculating it. I do want you to notice the formula given on 5A for formal charge is a little bit different than the formula given in your notes. It means the same thing, it's just stated differently. And just remember, in your notes, the formula was valence electrons minus lone electrons plus the number of bonds. And I often say lone electrons, the number of dots, okay? Dots plus bonds added together, and then valence electrons subtracted from that, okay? So the steps are here, and then you'll see the different problems after that. There is one typo on number 4. It should be H, capital C, lowercase l, O3, and there's a capital L there. So just notice that there's a typo there and fix that for me if you would. So I'm gonna leave this here so I can reference back to these steps, calculating formal charge and drawing a resonance structure for a particular molecule. This is a little bit different than typical Lewis dot. Why? Because one, a lot of these are ions, so electrons have been added or taken away from this group of atoms, and it's hard to say where, okay? So know that it's a little bit different, and when we're doing a resonance structure for formal charge, there's a set of steps, okay? And the steps are this: add up valence electrons of all atoms in the molecule. That's step 1, okay? So N has 5 valence, Y, position on the periodic table. O, each has 6, but there are 3 of them. 6 times 3 is 18. And then since there is a negative on this molecule, we're going to add in 1 more electron because the molecule has gained an additional electron. Okay, so adding in 1 extra because it's a negative ion. If the charge were -2, I would be adding 2. If the charge were +1, I would be taking away 1 of these electrons. Okay, so I add them up and I get 24 electrons, which I say 24 E negative. E negative is shorthand for electrons. So altogether we have 24 valence electrons. Step 1 is done. Step 2, draw a skeleton holding all atoms together, single bonds only at this step. So we draw a simplified version of a Lewis dot. How do we know what goes in the middle? Generally speaking, whatever you only have 1 of, that's what goes in the middle. Sometimes, like for later on in the worksheet, you'll see something like POCl3, where there are 2 things that we have to make a decision on what goes in the middle. In that situation, you choose the atom that can form the most bonds, okay? So anyway, we'll get to that in a second. But in general, the thing you only have 1 of goes in the middle, and then we're going to connect the oxygens to create a skeleton. Okay, single bonds only, check. Fill in the remaining electrons that have not already been accounted for in bonds. Keep in mind each atom's octet. So in these bonds, we have accounted for 6 electrons altogether. Why? Each line represents 2 dots being shared between those 2 atoms, right? So we have 6 electrons accounted for here. I'm going to keep adding in electrons until I get to all 24, okay? And I'm just going to start adding them around the molecule. They may not stay where they go. So this is the point that if I weren't making a video, I would switch to a pencil so that I can move electrons as needed, okay? So 6 electrons so far. I'm going to add them in pairs. That's 8, 10, 12, 14, 16, 18, 20, 22, 24. And I am now out of electrons, okay? So it says fill in remaining electrons, check. Now consider, number 4 is consider octets of each atom and make double or triple bonds where needed. So if we look at our structure and not everybody has an octet, we need to edit it, okay? So if we look, this oxygen currently has 8, 2, 4, 6, and then there are 2 represented by that bond. Same thing here. This nitrogen has 2 here, and then an additional 6 in bonds. So this nitrogen also has 8. This oxygen, though, doesn't. It has 2, 4, and then another 2 in this bond to make 6. So this oxygen does not have an octet, meaning we need to edit this structure to somehow give this oxygen another 2 electrons. What we do here is we make a double bond. So these electrons get moved into a double bond. So it's going to end up looking like this. Okay, So those electrons from nitrogen went into this double bond, okay? Now, nitrogen still has an octet. Each bond represents 2 electrons. 1, 2, 3, 4 bonds makes 8 electrons. Nothing changed about this oxygen. Nothing changed about that oxygen. This oxygen still has 2, 4, but it also thinks it has 2 more pairs in these bonds. So 2, 4, 6, 8 electrons. Now everybody is happy. Now, does it matter where you draw the double bond? No. Okay, it can be on this one, or this one. Any of those would be equivalent, okay? So we have considered our octets and added a double bond. You won't need a double bond on all of them. Some of them are fine with all single bonds and they're full and it's all good, okay? On number 5, calculate formal charge of each atom in the molecule. So now we're going to do the formal charge of each unique atom. There are 3 unique atoms here. N, single bonded O, and double bonded O, right? You see how these 2 are both single bonded, they're identical, but this double bonded O is going to be a little bit different, okay? So we're going to use this formula to find formal charge of each of these. Nitrogen has 5 valence electrons. We subtract out the number of dots. There are no dots on this, okay? We're going to add in the number of bonds. There are 4 bonds, so dots plus bonds equals 4. 5 minus 4 gives us plus 1. So nitrogen is plus 1. Now we're going to do single bonded oxygen. 6 valence electrons. We know that from the periodic table. We subtract out the dots. There are 6 dots. 1 bond. 6 plus 1 is 7. 6 minus 7 is -1. So there are 2 -1s. Okay. And then double bonded O, still 6 valence electrons. 4 dots. 2 bonds. Double bonded oxygen is 0. So I want you to see something. We have 2 -1s and we have a positive. So one of the positives cancels out one of the negatives. So the overall charge of this molecule is -1. Why? Twice as many negatives as there are positives. Does this check out with the formula? Yes. -1, -1, okay? So the formal charges should always add up to the charge of the molecule. If it's an ion, it should be the charge of the ion. If it's a neutral molecule, then the formal charge should be equal to 0. Okay, let's do another example. POCl3. Step 1, add up valence electrons. Excuse me. P is 5, O is 6, chlorine is 7, but there's 3 of them, that makes 21. There's no charge, so we're not accounting for any additional electrons. We add these up, 32 electrons. Step 1 is done. Step 2, skeleton with all single bonds. Remember, we have to make the decision about which of these is going to be the central atom. The one that can form more bonds is going to be the central atom, so phosphorus. And then we have an oxygen and 3 chlorines. Okay, step 2 is done. Skeleton, check. Fill in remaining electrons that have not already been accounted for in bonds. So we have 2, 4, 6, 8 electrons present so far. We're going to continue to add until we get 32. So 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We're out of electrons, so we're done drawing dots. Now, evaluate your octets. That's your next step, okay? Make double or triple bonds if needed. Only if somebody doesn't have an octet already, okay? Chlorine has an octet, oxygen has an octet, phosphorus has an octet. No double bonds are needed here, so we can go on to calculating our formal charge. Phosphorus, 5 valence electrons minus dots. There are 0 dots, and add in bonds. There are 4 bonds, so phosphorus is +1. Oxygen, 6 valence electrons, 6 dots, 1 bond, -1 charge. Chlorine, 7 valence electrons, 6 dots, 1 bond, 0. Okay, so then we say, okay, phosphorus is +1, oxygen is -1, and do these balance? They should, because there's no charge on this molecule. They do. We're done. Moving on. Okay, I'll do a couple more and then I'll let you practice. All right, HClO3. This is another situation where we have singles of 2 different elements. We have to decide which one is going to go in the middle. Hold up, I'm getting ahead of myself. We need to add up our valence electrons. H is 1, chlorine is 7, oxygen is 6, but there are 3 of them, so that would be 18. So let's see, 8 plus 18 should give me 24. Nope, 26. Sorry about that. Okay, so 26 electrons. All right, that is done. Now we have to make our decision about which one goes in the middle. Oxygen can't, because there's 3 oxygens. Hydrogen can't, because hydrogen only forms 1 bond to be like helium, right? So hydrogen can't go in the middle, so chlorine goes in the middle. Okay, then we have 2, 4, 6, 8 electrons tied up in bonds so far. We're going to keep going until we get to 26. We're not going to put any additional electrons on hydrogen because it doesn't want them, okay? So 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We're out of electrons, okay? Next we evaluate, does everybody have an octet, or is everybody happy? Oxygen has an octet, chlorine has an octet, hydrogen doesn't want an octet, it only wanted the 1 bond, so it's all good. Do we need any double or triple bonds? No, okay? Now we move on to formal charge. Hydrogen, 1 valence electron, subtract out dots, no dots, add in the number of bonds, so 1 minus 1 is 0. Hydrogen's charge is 0. Chlorine, 7 valence, 0 dots, 4 bonds, 7 minus 4 is plus 3. Oxygen, 6 valence, 6 dots, 1 bond, negative 1. So chlorine is plus 3. Each oxygen is negative 1. Does this add up? Negative 1, negative 1, negative 1. Overall negative 3 charge, positive 3 charge balances equals the charge of the neutral molecule. Okay, so that's all good. One more, last, save the best for last here. Add up your valence electrons. S is 6, O is 6, and there are 2 of them. Total of 18 electrons. Sulfur is going to go in the middle because there's only 1 of them. We got 2 4 electrons tied up in bonds, so we're going to continue to add until we get to 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay? Doesn't matter where we're putting them right now. Again, this is the point I would write in pencil, because the next step is to evaluate our octets. This oxygen has 8, this oxygen has 8, but this sulfur only has 2, 4, 6. So this sulfur is not good right now, okay? One of these oxygens, doesn't matter which one, is going to donate their electrons to a double bond. So it's going to become this, okay? Again, the double bond can be on the left or on the right, doesn't matter. But now this sulfur thinks it has 2, 4, 6, 8, so it's good. Oxygen still thinks it has 8, and we haven't changed this other oxygen, okay? So that's how that should look. We're going to do formal charge. We are going to have 3 unique atoms here. We have our single bond O. We have, I'm running out of space here, aren't I? We have our sulfur, and we have our double bond O, okay? For our single bond O, 6 valence electrons, 6 dots, 1 bond, negative 1 charge. Okay, so this guy is negative 1. For sulfur, I think I'm going to get a fresh sheet of paper because I'm running out of space here. Okay, so we decided that single bond O equaled 6 minus 6 plus 1, so it's negative 1. Sulfur, 6 minus 2 plus 3, 2 dots, 3 bonds, positive 1. Okay, and then double bonded oxygen is going to be 6 minus 4 plus 2, 0. Okay, these 2 balance out, they should. SO2 was our formula, and they are neutral. Okay, so that is how you determine formal charge if you also have to draw the molecule. If you don't have to draw the molecule, all you got to do is this part. Okay, please let me know if you have any questions.